Welcome back. Today we're going to talk about multiplying and dividing numbers in scientific notation. Okay, so if we say that light travels at a speed of 1.86 times 10 to the 5th miles per second, and it takes light from the sun about 4.8 times 10 to the 3 seconds to reach Saturn, what is the distance between the sun and Saturn? So let's think about this. Here's the sun, let's say, and let's say that this is another planet is Saturn. So if light is traveling in waves and this is the speed of light per second, okay, and we know the time that it's taking to go from the sun to Saturn, we can figure out the distance by taking the speed of light and the time it takes. So speed times time equals distance. Okay, so we're going to figure out distance by taking speed and multiplying it by time. Okay, so I'm going to take 1.86 times 10 to the 5th power, and I'm going to multiply that by 4.8 times 10 to the 3rd power. Okay. Now the first thing that I'm going to note is that I actually don't need parentheses, right? Each one of these are factors in a multiplication problem. So no big deal. I can use the associative property to actually drop the parentheses. And while I'm at it, I'm actually going to use the commutative property at the same time to move the coefficients next to each other, and then the powers of 10 next to each other. And it's going to become obvious in just a second why I'm doing that. So let's see, I have 1.86 times 4.8 times 10 to the 5th power times 10 to the 3rd power. Okay, so again, I just used the associative property to drop these parentheses. I don't really need them. It's just a bunch of numbers being multiplied together. Okay, and then I use the commutative property in order to rearrange it so the factors can be next to each other, right? Or the coefficients can be next to each other, and then the powers of 10 can be next to each other. Well, these two numbers are just regular numbers, and these two are powers with the same base. So all of these things I know how to multiply, okay? I know how to multiply 1.86 times 4.8. That gets me 8.928. Okay, so I have 8.928. You could do that on a calculator. And then I'm going to multiply that by, well, the powers of 10, 10 to the 5th times 10 to the 3rd is going to get me 10 to the 5 plus 8, because this is the product of powers. So we have 10 to the 8th power. All right, and it's just as simple as that. So I took two numbers that were in scientific notation. I rearranged them so that the coefficients were next to each other. I multiplied the coefficients just like regular numbers. I took 1.86 and I multiplied that by 4.8, okay? And I got 8.928. And I took the powers of 10 and I multiplied them, but we know that when we take the powers of 10, they have, like bases, so I can just keep the base and add the exponents, and that's it. Fortunately, my number actually ends up in scientific notation. It's not always going to be like that, but for us, it was pretty good. And so this right here, since it was in miles per second, and this was in how many seconds it took to reach Saturn, my units for my answer is going to be this many miles. So the distance between the sun and Saturn is 8.928 times 10 to the 8th miles. Now let me see, 10 to the 6th is millionths, so 10 to the 8th is 100 millionths, so it's about 900 million miles away between the sun and Saturn. Oops. Okay, so that is the answer to my question. Okay, if we want to talk about dividing numbers in scientific notation, then we can think about this word problem. Light travels at a speed of 1.17 times 10 to the 7th. This is in miles per minutes now, not miles per second. And Pluto's average distance from the sun is this many miles. On average, how long does it take the sunlight to reach Pluto? So remember, an average distance, that's because when Pluto is, so here's the sun, right? And Pluto is traveling this elliptical orbit around the sun. So it's traveling like this path around the sun that's actually an ellipse. So sometimes it's not a full circle. So sometimes it's pretty far away from the sun, and sometimes it's pretty close to the sun. So when we talk about average distance, you take the average between the longest distance away and the shortest distance away to create an average. Okay, and so at that time, it takes. Well, actually, we don't know how long it takes for the sunlight to reach Pluto. That's part of the question. And actually, this should be capitalized. So remember that we have a classic distance equals rate times time, or speed. I can think of rate as speed. Speed times time. So if I'm solving this for time, it would be distance divided by speed is equal to time. So if I take the distance it is away from the sun, and I divided it by the speed at which light travels, then I can find the time, okay? So the distance here is, let me write this in scientific notation. It's 3.67 times 10 to the, 369 divided by, okay? And it's going to be divided by 1.17 times 10 to the 7th power, okay? Now, what I want to do is I want to use this little trick, and let me show it to you real quick with just a simple fraction. If I have 2 times 8 in the numerator, and I have, let's say, 3 times, I don't know, 16 in the denominator, okay, what I can really do is I can actually split up this, the product. We can split up the numerator and denominators into 2 separate fractions. Okay, and I can say, okay, well, one of the fractions can actually be reduced, so this would be 1/2, and then I can multiply them back together again to get what the fractions are reduced. So it'd be 2/6, and actually now I can reduce it even further, all right? So the trick is taking something, a product in the numerator and the product in the denominator, and making 2 separate fractions. So what I'm going to do is I'm going to take 3.67, and I'm going to take 1.17, the coefficients that is, and I'm going to make them into their own fraction. And then I'm going to take the powers of 10 and make them into their own fraction, okay? And that's because we are going to divide them using different rules. The rules for dividing, I'm just going to use the rules for dividing normal numbers here. So these 2 numbers, if I take a calculator and divide those 2 numbers together, I get 3.14. So I did this on a calculator beforehand. So these 2 numbers divided by each other are going to get 3.14. And then times. Now remember your rules for dividing powers with the same base. I keep the base and I subtract the exponents. Okay, so I'm dividing all parts of this. I'm taking this entire number and then I'm dividing it by the number in the denominator. But I just, the coefficients, the numbers themselves divide differently than the powers of 10 with the like base of 10. Okay, so I took the coefficients, I divided them, and I took the numbers and the powers of 10 and I divided them in the way in which we just learned. Okay, now so fortunately our numbers, again, it lands in scientific notation, so I don't have to modify it in any way in order to get it into scientific notation. Let me investigate the units here. So, so this should be in seconds because it was how long, the answer was how long. Oh, it's actually in minutes, sorry, because that was the speed was given in minutes. So it takes this many minutes. If they ask for the answer in standard form, well, I would just multiply it by 100, so it would be 314 minutes. Okay, so it depends on how they indicate they want the answer. So it will take 314 minutes for the sun to reach Pluto. All right. Now I want to investigate a situation of 2 numbers that when you divide them, you do not land, the number that you get does not land in scientific notation, because I want to look at what happens here. So let's say we take this number and we need to divide it by this number. Okay, so first let's think of the coefficients by themselves. So these coefficients, let's divide these things by themselves. And then we're going to take the powers of 10 and divide them by subtracting their exponents, okay? So I actually did this beforehand. So when we take 3.56 and we divide it by 6.58, we're going to get 0.54 times. Now 8 minus -3, if we use KCC, we'd have 8 plus 3, so we get 11. So this is 0.54 times 10 to the 11th power. Okay, so this number that we get is not in scientific notation. So we're going to use the rules that we learned in the last lesson to put it in scientific notation. So I'm going to increase the coefficient and also decrease the power of 10. So remember, they work inversely. So if I make the coefficient larger, I have to decrease the power of 10. Now this is my final answer. So if they ask me what my final answer is in scientific notation, and the number that I get is not in scientific notation, then I'm going to have to use the rules that we showed, that I showed you in the last lesson in order to transfer it. Okay. Now, scientific notation on a calculator. So if I take my calculator and I want to divide these two numbers on a calculator, I'm going to show you the keystrokes you're going to use. Bear in mind that a lot of the times we're not going to use a calculator to do these problems. Okay. Okay, to do these problems in a calculator, there's actually this key right here, which is a times 10 to the. Okay, I say times 10 to the because it takes whatever you've written and it makes it the coefficient, and it adds times 10, and then it puts the blinker up in the exponent. So to do the last, let me clear this out, to do the last problem, I'm going to write 3.67 times 10 to the 9th power. Okay, notice that my blinker ends up in the exponent, so I want to press the right arrow and I want to divide this by, okay, and let me use parentheses to put the entire thing in the denominator here. Or if I want, I can actually make it into a fraction. So 3.67 times 10 to the 9th power, and then I can go down so that I can get into the denominator, and then it was 1.17 times, oops, let me go over and use the times 10 to the exponent of 7, okay? And if I go to the right here so that I'm on the side, I can press enter and it will give me the 300. So you'll notice the number that it gave me was not in scientific notation, okay? So what I can actually do, there's a mode here, and I can go down and I can go over, and this mode right here, when it's in this mode, you rarely want this in this mode, but when it's in this mode, it will put everything in scientific notation. So if I arrow up here and I press enter again, it should give me the number in scientific notation. So that was what I was saying. It was 3.1, and I estimated it to be 3.14 times 10 squared. Okay, so that's the way you could do it. You rarely want your calculator in this mode, because whenever you're in this mode, scientific notation mode, if I write like 6, for instance, it's going to give it to me in scientific notation. If I write 10, it's going to give it to me in scientific notation. Okay, it's nice to have it sometimes, but you know, if you're trying to do regular calculations, it's not so helpful. All right, so you can always go back to mode, go down and hit normal, and then second quit in order to get out of it. All right, and that's the end of the lesson for today.